Okay, we've got three equations here. What is sin x going to look like? It starts here, goes to 1, which I'm going to zoom in actually. Alright, try that again. Okay, starts here at the origin, goes to 1, and then, sorry, it's actually there. -1 is here, and 2 pi. Okay, so there's your sine graph. Like so. What happens when we have sine 2x and the b value is 2?
It will compress.
It'll compress, won't it? So we're squeezing it so that we get two cycles or two wavelengths within 2 pi. So now it's compressed like this, like so, and like so. Okay. What happens when we have sine half x?
It will spread out.
It'll spread out, that's right. So when we've got fractions or values smaller than 1, it widens, stretches. So instead of one cycle within 2 pi, I've got half the cycle. So that means that it's going to top there and finishes there.
Yeah.
So what is the wavelength going to be? How much is one wavelength?
Half.
It's not
Oh,
going to be
4 pi.
It's 4 pi. Well done, Levi. So now we've got that. So the wavelength is essentially doubled, right? So we could say then that the value b is equal to 2 pi divided by the wavelength. Okay. As this, when we had up here, when we had b is equal to 2, then the wavelength is lambda, which we can calculate. Now we can
So it would be
diagonally swap those two and say that the wavelength is 2 pi divided by 2,
which would be pi.
which is pi. Okay, so you can see that one wavelength is there, it's at pi. Down here, if we said half is the value of b, then we can calculate the wavelength by swapping those two, and we can say that lambda is equal to 2 pi
On 1/2.
on 1/2, which is the same as 4 pi.
Yeah.
Okay, we can see that that's 4 pi. Okay, so let's try a couple of these. Let's say that I want the sine curve that reaches 5 pi. That means halfway is going to be here, and half of that, now it's going to be 2, 4, 6, 8, 10. So 5 is there, and then 2, 4, 5 is there. Okay, so I want the sine curve that goes like that. What is the value of b? Sorry, what is the wavelength?
5 pi.
5 pi.
Yeah.
So 5 pi is equal to 2 pi divided by b. Now I can swap those two around and say that b is equal to 2 pi divided by 5 pi.
So
Pi's
Zero
cancel.
0.4.
True, 0.4 or 2/5. So in other words, I've got 2/5 of a wavelength going through 2 pi.
Yeah.
Okay? So if b is equal to 2/5, that means 2/5 of the wavelength goes through 2 pi. So there's 2 pi, and that's 2/5. That means that's 1/5, 3/5, 4/5, 5/5.
Yeah.
Make sense? Alright, let's try this one. Give me the equation of the sine curve that has a wavelength that is 11 pi.
So would it be so would it be 2 pi? So it would be 2 and 11. 2 11ths would be 11. 2 11ths would be B, wouldn't it?
B is equal to 2 pi divided by the
11.
wavelength, which is 11 pi.
Yeah.
So 2 11ths would be the value of B. Okay, so let's type it in. So we're looking at 2 over 11 x. Okay, let's just rub this out and we'll type it in. Looking good so far? 8, 10, 11.
Yeah,
Nailed it.
I think.
Okay, let's pause there.